We have seen what single item flow in a well-balanced line looks like in a perfect world in which every step takes exactly the average cycle time. In practice, that is not the case, but there is considerable variation, in particular during manual processes like welding or assembly. We are simulating this using a normal distribution around the expected cycle time, which is 1 minute each. So it could be a little more, it could be a little less than a minute. And we already see here at the first station that a work in process is building up. There are already 2 parts at the welding station. Instead of the first part moving forward, it's still being worked on apparently. And as we keep going, quantity is even increasing. And as you know, this is very realistic in any real environment. And the key is that due to this variation, we don't get the benefits of the balanced line in which all of the stations work in parallel all the time. Here instead, we see the work in process being unequally distributed. So now we have 2 at the assembly station 1. And only if we are really lucky, the process finds its minimum WIP steady state. So also right now, it seems we are having a good series of work orders coming through, and the WIP is very manageable. But again, it can well be that we reach congestion again. And so here we are. Now we have 3 items in a line. And so the question is now how to deal with this. First, you can use Optio to track these kind of things. You will be able to track your average WIP. You will see what process variation does to you. And you will be able to decide on where you might want to employ automation or lean continuous improvement to actually reduce your process variation. We now simulate the same process again, but this time we set the cycle time at the welding station to be constant, simulating a welding robot, and leave the cycle time at assembly 1 and 2 subject to random fluctuations. The first lot is already being released. So the first weld is complete. The second will follow shortly after as the process is working at constant pace. And we now see things getting stuck in assembly. And as welding keeps producing at 1 minute per cycle rate, assembly might take a little longer or be done a little earlier, which leads to the WIP imbalance that we've been seeing previously. So the problem is now really shifting from the first one that you solved to your assembly, which will require lean continuous improvement or additional automation to also reduce process variance here to truly achieve single item flow. So while this might look like there is no real improvement, the process actually moves a lot faster with every station that you make more consistent. Every time you do that, you increase flow, you reduce lead time, and you reduce the overall WIP in the station. You can address these problems one by one using the tools and machines that are available to you.